Okay, 2.2 is on surds, which again you might be familiar with from GCSE, but we're going to be looking at them slightly more advanced level. So surds are roots of integers that aren't square numbers. E.g. root 2, 2 is not square, root 3, root 21, etc. So it's roots of numbers that you can't simplify anymore. And there's a few rules that go along with surds as well. So the root of AB can be split up into root A times root B, and root of A over B can be split up into root A over root B, which kind of comes from the index rules as well. You can explore that bit if you want, but it all kind of links together. So just a quick few examples of using those rules. So simplify root 24. So we're going to try and split root 24 up into a square number and a prime number, or a non-square even. So root 24 we could say it's root 4 times 6 is 24. And then using the rule we can split that up into root 4 times root 6. We know root 4 is 2, so we can say this is equal to 2 root 6. Because 6 isn't square, we can't actually split that up anymore. Alright, if you guys would like to try one. So if you guys would like to try this one, so pause the video and give it a go. Alright, so because we got root 6, we saw earlier we can't actually simplify that anymore. We're going to try and split both of these up into some amount of root 6's. So keep 5 root 6's in. Root 24 we saw earlier, we can split up like this. We'll say it's 2 times root 4 times 6. And the next one we can say it's plus root 49 times 6. So root 4 again we can split up, and root 49 we can split up as well. So I've used my rule again to split up these into two sets of square roots, and now we can just go through square rooting the squares. So 5 root 6 minus root 4 is 2, 2 times 2 is 4, 4 root 6, and root 49 is 7 root 6. So 5 root 6's take 4 root 6 plus 7 root 6 is going to be 8 root 6 overall. Alright, let's try one more, expanding some brackets. So we're going to try and expand this, so we can say, well, 2 times root 3 is 2 root 3, then root 3 times root 3. But if you've got root 3 and you're timesing it by root 3, you're going to end up with just 3. So we can combine those two again. Root 9 is 3, so 2 root 3 plus 3. So generally you can remember if you've got two roots of the same thing times together, you just get rid of the root sign. Okay, rationalising denominators. I'm going to put up a bit of text, so if you want to, I'll fast forward if you want to copy this down and we'll talk you through it. Okay, so dividing by a surd is hard because you're dividing by a number that's not whole and never simplifies, so you get into a bit of a mess. So instead of dividing by surds, what we do first is we rationalise the denominator. So a surd is a number that's not rational. Rational means it doesn't go on forever, not repeating. So to turn a surd into a rational number, as you saw in the last example when we times root 3 by root 3, you can rationalise the surd root 3 by timesing it by itself and getting a rational number. So when we've got a fraction that has a surd as a denominator, we can try and times the whole fraction by the surd, and it will turn the denominator rational and make it into a number. For example, so if we wanted to rationalise 1 over root 2, we need to times root 2 by itself in order to cancel out the square root. So we're going to times the top and the bottom of the fraction by root 2. So we get 1 times root 2 is root 2, root 2 times root 2 is 2. Now the reason we got times the top and the bottom is because if you're not timesing a fraction by the same thing on the top and the bottom, you're changing a fraction. Root 2 over root 2 is 1. So we're really just timesing this fraction by 1. So we're left with the same thing, it's still the same fraction, but it now has a rational denominator, so it's more mathematically good, mathematically nice, whatever you want to call it. So rationalising the denominator doesn't change the fraction, because you're only timesing it by 1, but it makes its denominator rational. So that's the simple type, and the rule for that one is 1 over root a times by root a over root a, and you end up with root a over a. But there are some more difficult types of these as well. So here are all of our rules for rationalising denominators. So there we go, you need to memorise these. So we saw this one already. If you've got 1 over a plus root b, you times it by a minus root b over a minus root b. That makes sure that the middle term when you expand these cancels out, and same again for this one. So we'll go through some examples of why these work. So e.g. 3 plus root 5. So according to the middle rule, we're going to times this by 3 minus root 5 over 3 minus root 5. Remembering it's got to be the same on top and bottom. So 1 times 3 root 5 is going to give us 3 minus root 5 there. And bottom, we've got to expand this like it's a quadratic. So 3 plus root 5 brackets times 3 minus root 5 brackets. So we're going to simplify and expand this denominator. So 3 minus root 5 over 3 times 3 gives us 9. 3 times minus root 5 is minus 3 root 5. 3 times root 5 is plus 3 root 5. And root 5 times minus root 5 gives us minus 5. So you can see now then, the middle two terms are going to cancel, so we've got minus and plus the same thing. So we're left with 9 take 5, which is 4. So that becomes 3 minus root 5 over 4. Denominator is rational. And that's the reason we've chosen the opposite sign, so that this middle term cancels itself out. And it wouldn't do that if you had the same sign in each term. Okay, let's try some slightly harder examples then. Okay, 4 examples. You're welcome to pause the video and try them. They're all pretty simple if you just follow the rules in the example we just did. But pause it if you want, and I will start working through these ones now. So, to rationalise 1 over root 3, we're going to times the top and the bottom by root 3. So 1 times root 3 is root 3, root 3 times root 3 is 3, done. Rationalise this one, we need to times it by 2 minus root 5 over 2 minus root 5. So 5 times 2 is 10, 5 times root 5 is minus 5 root 5, over 2 times 2 is 4, 2 times minus root 5 is minus 2 root 5, 2 times root 5 is plus 2 root 5, root 5 times root 5 is 5, so we get that. So we get 10 minus 5 root 5, those two middle terms are going to cancel. 4 take 5 is minus 1. So the whole thing becomes minus 10 plus 5 root 5. Okay, next one. Rationalise this one, so we're going to times it by 5 plus root 2. And it's just kind of designed to catch you up, because it's already 5 plus root 2 on top. But we ignore that, we're just opposite of this one. And we've got to be careful how we expand these. So root 5 times root 5 is 5. Root 5 times root 2 is plus root 10. Root 2 times root 2 is plus 2. And root 2 times root 5 is plus root 10. Denominator, root 5 times root 5 is 5. Root 2 times root 5 is minus root 10. Root 2 times root 5 is plus root 10. And root 2 times root 2 is minus 2. So now we can simplify this. So on top, you get 7 plus 2 root 10. And on the bottom, 5 take 2 is 3. Root 10 cancels each other out. So the whole thing, 7 plus 2 root 10 over 3. Okay, last one, same idea, but it's presented slightly differently. Write this in the form this. Well, you can tell the denominator here isn't rational, it's got root 5 in it. Here there is obviously a denominator of 1. So it's asking us to turn this into a denominator of 1 via rationalisation. So we're going to times this one. By root 5 plus 1. And then simplify. So timesing the tops out. 3 root 5 plus 3 minus 10, because we got root 5 times root 5, which is 5, times 2 is 10, and then minus 2 root 5. All over root 5 times root 5 is 5, times 1 is plus root 5, root 5 times minus 1 is minus root 5, and then 1 times minus 1 is minus 1. Okay, so simplifying this one, again those terms cancel out as they have done all the way through everything. Then we can simplify the top. So we get 3 take 10 is minus 7, 3 root 5 take 2 root 5 is plus root 5. Divided by 5 take 1 is 4. So we can simplify this a bit and say it's equals minus 7 over 4 plus root 5, plus a quarter root 5. So P is minus 7 over 4 and Q is 1/4. Cool, alright, that's it for Surds. So if you want to move on to the quiz, and then I think we've got one more bit left this week, which is a bit on factorising quadratics, which is a really useful skill anyway. So on to the quiz, and then back for the last video of this week.